एक काढू का? काढून बघू का? हॅलो हॅलो, दिसतंय? दिसू येत नाही. हा, हे जवळ असतं पण बोर्ड दिसेल का? बोर्डला लाईट मार. याला दिसणार का रे बघ? हा, दिसतंय? ओके, इझी वाला. स्क्रीन केवढी आहे? कुठून कुठपर्यंत? हे बघा. हा, कुठून कुठपर्यंत जात आहे ते? इथे बघा, दिसतंय? एकदम राईट कॉर्नर आहे. इथे आता दिसतंय का? बघा लास्ट लाईन इथे लास्ट कॉर्नर. आणि हा पूर्ण दिसतो. Signals and systems. Okay. So your subject name is signals and system. Basically, in this subject, we have to see total 6 units are there. 6 units are there. So in the 6 units, in first unit you have to see what is meaning of signal, what is meaning of system, and the types and the classification of signals and systems. So basically, what is a signal, what is a system, what is its types, classifications of signals and systems, you have to see in unit number 1. So basically, we can say it is the introductory unit for the signal and the system. Second unit, you have to see LTI systems. LTI system, meaning of LTI system is time invariant system, which is not dependent on time. So time invariant or time नुसार vary होता किंवा नहीं होता. So time LTI system we have to see, and this we have to see city convolution and GT convolution. So that's it. Okay. So in general, we have to see what LTI system in second. Third, we have to see Fourier series. I hope you have done something related Fourier series in M3. तुम्ही काय A0, B0, A and B and काढत होता का? So that is the representation of your Fourier series. A0 plus summation of this to this, A n this sin cos whatever plus B n summation of this. So this is the representation. But that representation we have to apply for the signals. If signal is periodic, what is the equation? If signal is aperiodic, what is the representation? So a time domain signal, any signal. It is simple as sine wave. It is periodic. So how will you represent this time domain signal into Fourier domain? Fourier domain means it is a frequency domain. So what? Why? We are getting time domain. Time domain signal will give you time information. कुठल्या टाइमला हा ऍक्सिस काय आहे? ही ऍक्सिस आहे. कुठल्या टाइमला त्याचा सिग्नलचा एम्प्लिट्यूड किती आहे? माझा सिग्नल काय आहे? सो टाइम ऍक्सिस काय देतो? टाइम इन्फॉर्मेशन. सो इट इज कॉल्ड एज अ टाइम डोमेन सिग्नल.
Frequency मध्ये काय देतो? It will give you frequency information. At what time which frequency is present. Okay, so that's why we have to go for frequency. And when we deal with city signal, it is called as Fourier series. When we go for DT signals or then it is called as Fourier transform. Periodic, that is okay. But whenever CT signal, we go for series. And when DT signal, we go for so fourth unit will be Fourier transform. Fifth will be Laplace transform. So in this Laplace, we go with S domain signal. We go with S domain signal. Okay, and the last unit is probability. I hope you know tossing of coin, throwing of a dice. Yes. There are a box or with 3 green, 4 blue. Find the probability of this and that. Okay. That simple probability. Then some rules of probability. Specific rules of probability, or we can say properties. So properties of CDF and PDF. Then random variables. Okay, random variables, and then autocorrelation and cross correlation. So these basic concepts of probability, random variables, and this we have to see in unit number 6. So this is designed as per unit 1 to 6. So this we have to study. Those who are online, you can take care that everything is recorded. I will provide the recorded link also, but nothing is repeated. आता कुठलंही काही रिपीट होणार नाही. कारण काय? Already we are running late. Direct second year आले त्यामुळे तसंही घ्यायचंच होतं ते. So from this time onwards we are starting the SS. असं आपण कन्सिडर करू आणि इथनं पुढे आपण प्रोसीड करू की आता SS चं पहिलं लेक्चरच असं जमलं आणि we are starting SS. Simple. Those who are coming regularly, they come with notebook. जे ऑनलाइन अटेंड करतात त्यांनी एक लक्षात घ्या की आपण जे करतोय ते नोटबुक मध्ये लिहायला पाहिजे. कारण काय होतं एसएस दिस काइंड ऑफ ऍक्च्युअली दिस काइंड ऑफ सब्जेक्ट की आज जे झालं उद्या जर विचारलं तर येत नाही. एव्हरीथिंग शुड बी इन युअर नोटबुक. तसं करायला लागेल. ठीक. We'll see what is the signal. First, we'll see what is meaning of signal. Signal is simply, we can say it is a it can be, we generally define a signal, it can be a physical quantity. It can be a physical quantity which carries some information. This will be a physical quantity which carries some information which will depend on one or more variables, dependent or independent. So dependent variables or independent variables. So in general, signal is a physical quantity that will be carrying information which will be one or more independent variables. So simple example of your signal will be a simple sine wave. So
will be a simple sine wave, which will be represented by x of t, where t is this variable. So simply we can say it is a dependent or independent, dependent on one variable, that will be a time. That will be a time, and this will be the amplitude axis. Barabar, amplitude versus time, sine wave, and this signal will be represented as x of t is equal to a sine omega t, right? Where your omega is equal to 2 pi 2 pi f represent the frequency. So this is the basic simple example of signal. That can be anything. Your then we start with the example your AM, FM, then your telephonic waves. So anything can be considered as a signal. Second thing, what is meaning of system? System can be considered as your input to the system will be x of t, that is your signal is the input to the system, which will produce some output which is called as a y of t. So system can be this box which will perform some kind of operation. Simple way, system will perform some kind of operation on the signal, or some kind of processing done on the signal, which will be called as a system. A simple, very basic example. See, this is my input. I want double input. I want to double the input. I want to double the input. So simply my system is multiply with 2. So this y of t will become 2 x of. So this multiplier factor can be a system. So simply a system act as a multiplier. Understand? Next, very basic example is, see, your transmitter, the input signal or audio signal is given to the transmitter. It will transmit through channel. It will receive at receiver's end. Simple, your radio system. Transmitter will transmit through a wire medium or through a wireless medium. Through air, it will travel, that is your channel. And receiver end, it will be received. And again, it will be output is in the audio form. इकडून ऑडिओ पाठवला, इकडून ऑडिओ आला, बरोबर आहे. मग हा जो ब्लॉक आहे, this block, can I call it as a system? Can I call it as a system where the input to the system is audio, the output of the system is audio, but the processing is transmission, channel, and then receiver. So this total is called as a system. Input to the system, and which will produce some output. So this is generally anything. Your say a half wave rectifier. A half wave rectifier, simple half wave rectifier. Input is sine wave. Half wave, either it will have positive or either it will give negative. So input is sine wave, output is half wave. So that rectifier called it as a system. Input, output. So any electrical circuit, any electronic circuit is called as system, which will
get some input which will produce some output. That's what we call that as system. Simple, hai? How many? 48. Yes, 48, 9, 10, 11, 50 by you have strength of 70. No? So half 60%. Now, there are two types of signals, C, T and D. What is the meaning of CT signal? Any signal which will be continuous with respect to time. Any signal which will be continuous with respect to time. Any signal. We can say bit signal, then your cos signal, then your sine signal. Any signal which will be a continuous with respect to time. It can be a periodic, it can be a periodic signal that can call as a switch. What is meaning of DT signal? Which is not continuous. In simple way, which is not continuous, that is called as a discrete signal. And your values are 0, 1, 2. Always there is no floating value, only the integer. Either positive or negative. Simple. Process to convert this continuous to discrete, which is called as a process which will convert your continuous signal to discrete signal, which is called as sampling. And this sampling comes with your sampling error. Generally, you know what is the process? Sample and hold circuit is there. Sample and hold circuit माहिती आहे का? हाँ? काय असतं? What is sample and hold circuit? It's just a switch. It's just a switch which is called as a sample and hold circuit. इथे मी तुम्हाला काय दिला analog signal दिला. म्हणजे काय हा on असेल, off, on off, on off, on off. म्हणजे हा काय करेल? It will chop the signal. It will chop the signal. Second thing, what is second? Chopping झाल्यानंतर आपल्याला काय पाहिजे? Quantization. Quantization. Quantization म्हणजे काय? जे काही appropriate त्याचं amplitude असेल, which will be converted to nearest integer. Nearest integer. समजा आता त्याचा amplitude आहे 1.3, so it will convert it to 1. If it is 1.57, it will convert it to म्हणजे काय 0.5. 0.5 च्या less असेल, so it will convert it to below integer. If it is 0.511 पेक्षा मोठा असेल तर depend on how we design our quantization. And then the next step is encoder. This is the sampling process. Okay. So what is sampling theorem? A continuous, काय म्हणतो लक्षात घ्या. A continuous signal is converted to discrete, and it is converted back from its discrete to original form when the sampling frequency is greater than or equal to twice of maximum frequency of a signal. काय म्हणतो बघा, जी सॅम्पलिंग फ्रिक्वेन्सी आपण यूज करणार आहे, व्हॉट इज सॅम्पलिंग फ्रिक्वेन्सी म्हणजे काय? जी काय आपल्या फ्रिक्वेन्सीने आपण त्याला चॉपिंग करणार आहे. सॅम्पलिंग फ्रिक्वेन्सी which will be greater or equal to twice of f max. F max म्हणजे काय? जो काही सिग्नल आहे हा सिग्नल आहे माझा, याची जी काही मॅक्सिमम फ्रिक्वेन्सी आहे या सिग्नलची, कुठला इनपुटचा सिग्नल, याची जी काही मॅक्सिमम फ्रिक्वेन्सी आहे, twice of that will be my sample or greater. Either it will be twice of f max or greater. म्हणजे मला काय, माझी जी दिलेला इनपुट सिग्नल आहे त्याची जी काही मॅक्सिमम फ्रिक्वेन्सी आहे, समजा सिंपल आहे 5 हर्ट्झचा सिग्नल आहे, म्हणजे मॅक्सिमम फ्रिक्वेन्सी किती? 5 हर्ट्झ. आणि मग मला सॅम्पलिंग रेट काय लागेल? 10 हर्ट्झ. or then and then my sampling theorem is valid. And this is called as Nyquist criteria. Nyquist. So sampling frequency is always greater than or equal to twice of f max. Fs is the sampling frequency, f max is the maximum frequency of a signal.
Sir. Hello, sir.
So basic understanding of city signal and entity signal, that is okay. Now we'll move to some basic signals are used in signal system. Okay. So first signal I'll write in CT and DT form. Okay. So simply this signal, which will be at 0, amplitude approximated to 1, and this signal is called as delta of t. So delta signal, delta of t. Because delta कैसा represent करना? Just represented by this at 0, that is amplitude 1, which is called as delta n. Your signal here, it is x of t continuous असल्यामुळे, आणि इथे सिग्नल काय म्हणणार? x of square bracket t म्हणजे continuous, n म्हणजे this is what delta is. Then second signal, this kind of signal is there, which is called as u of t. u of t is step signal. Step signal म्हणजे काय? Starting at 0, ending at infinity, and with amplitude, So how will you draw a DT signal of this? Starting at 0, 1, 2, 3, up to infinity, dot 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 dot. This is what? This is your n. This is n. This is u of. Simple. So how will you represent this? Delta of t is equal to 1. Delta of t is equal to 1, where t is equal to 0. Otherwise it will be 0. हा सिग्नल कसा रिप्रेजेंट करणार? u of t. u of t is equal to 1, where t is greater than or equal to 0 किंवा 0 पेक्षा जास्त. ठीक आहे. सेम तसंच ते n मध्ये होतं. आता इकडे अजून काय? This is called as r of t ending at infinity, which will be a linearly increasing set. It is called as a ramp signal. It is called as a ramp signal. If you draw in DT line, 0 la 0, 1 la 1 amplitude, 2 la 2, 3 la 3, 4 la 4. बरोबर आहे? Amplitude वाढत जाणार 0, the 1, the 2, the 3, the 4. This will be 0, 1, 2, 3. This will be n. This is r of n. This is r of t. Yes. So how will you represent this signal mathematically? R of t is equal to R of t is equal to directly can say t. Say t is greater than or equal to then what else? A signal which is called as a rectangular pulse. Rectangular pulse. So it is tau by 2, this is plus tau by 2, this is what? Say A is the amplitude of the signal. Same you can write for DT signal. So I will not draw each and every signal. You can see your notebooks which different standard signals are used in signal system. Remaining is sine CT signal, sine DT signal, then cos CT, cos DT, then exponentially increasing, exponentially decreasing. Okay, then your sync function. Those who are not getting, you can see your notebooks. So this a signal. हे signal आपल्याला use करायचे signal system मध्ये. या signal वर आपल्याला we have to perform some operations. Okay. करते. हे माझा आपला homework आहे की मला कुठले कुठले standard signals आहेत signal system मध्ये. त्याचं CTचं representation काय, त्याचं DTचं representation काय, and त्याचं mathematically expression काय. How will you write mathematically? There are two ways to draw a signal. Either you write x of t is equal to a sine omega t. म्हणजे काय, मला sine signal दिले. Or you can directly draw sine. So by mathematical expression we have to define a signal, or by drawing a signal we have to define a signal. कुठे कुठे तुम्हाला काय करायला लागेल, ड्रॉइंग काढावं लागेल. कुठे कुठे तुम्हाला mathematically solve करावं लागेल. That is what signal system is all about. 54. So there are various classification or signal classification of signal. There are, first is energy signal or power signal. We have to classify signal into energy and power. Second, we have seen this side is even signal and odd signal. Third is periodic signal or aperiodic signal. Fourth is deterministic or indeterministic. So that is, fourth is not at all important. We have to see main three classifications: energy, power, even odd signal, or periodic and aperiodic signal. Mainly the numericals are asked for these three types. They will give you a signal, they will ask you whether it is energy signal or power signal, and if energy or power, find its energy or power. काय तुम्हाला एक तर पहिलं तर सिग्नल एनर्जी का पॉवर तो शोधायचा, आणि तो शोधल्यानंतर if it is energy signal, what is the energy? Then the question will be asked like, the signal is given to you, whether its signal is periodic or aperiodic signal, and if periodic, what is the period? And then In that case, I guess they will give you a signal mathematically or draw. And they will ask you to draw even and odd components of this. Or find even and find means they will give you some expression and they will ask you what is the even signal or what is the odd signal. Okay. So we have seen this. We'll again see this. This is comparatively this is easy. So first today we will see this and tomorrow this too. So it is already we have taken even and odd signals. So directly we will see what is even. So even signal which is represented as xc of t. I will write now. जेव्हा जेव्हा मी t लिहितो मी continuous बद्दल बोलतो. जेव्हा जेव्हा मी x n लिहिणार आहे मी discrete बद्दल. So that is keep in your mind. And which is also applicable to n. जे मी equation t साठी लिहिली तेच equation n साठी applicable. Okay. So simply x of t is equal to 1 by 2. We have to find x of t plus we have to find x of minus t. Yes. So meaning of this is the original signal given to you. This is the folded signal. This is the folded signal. म्हणजे काय जर +1 ला जो काही सिग्नल असेल तो कुठे जाईल -4. Simple meaning is this: if this signal is given to you, what is minus version? म्हणजे इथे समजा 3 होता, इथे काय झाला असेल? इथे सेंटरला जर 2 होता, इथे काय झाला असेल? Simple. It is just a folding or mirror version with the origin. With the origin. So this is your called as a even component of the signal, and which will be odd component. Odd component is 1 by 2 x of t minus x of minus. म्हणजे मला काय करायचं या ओरिजिनल सिग्नल मधून फोल्डेड सिग्नल मायनस करायचा आणि त्याला बाय 2 केलं तर मला ऑड सिग्नल मिळेल. ओरिजिनल सिग्नल प्लस फोल्डेड सिग्नल बाय 2 केलं तर मला काय मिळेल? take example कुठलं घेतलं होतं आपण एक्झाम मला आहे का एक्झाम्पल घेतलं होतं इवन ऑर्डर्स आपलं कुणाकडे आहे का ओके ते मॅथमॅटिकल घेतलं मॅथमॅटिकल नाही आपण ड्रॉइंग मध्ये पण घेतलं होतं ठीक आहे आले का अलीकडे तिकडे नाही तेच so I'll draw directly you can now think but in signal system the imagination power is most important. If I drawing something, we have to imagine how it is folded or how it is get shifted. So this is what a signal given to you. The x of t is given to you. This is -1. This is 0 position. This is simply draw it as a 1. This will be. So what is the amplitude? Amplitude will be. We can consider that one. Now signal is given to you. They have asked you what is the even and odd component of this signal. Okay. So what is my first target? This is here. Always you have to write t. While at the time of drawing, whenever you are drawing the axis, you have to write which is this axis, which is this axis, and what is the points on the axis. So see, 1 is here. So if I draw this signal, 1 is here, -1 is here. So like this, like this. बराबर है? फोल्ड केला सिग्नल म्हणजे हा पार्ट जो आहे तो इकडे गेला, हा पार्ट जो आहे तो इकडे गेला. ओके, बरोबर आहे. दिस विल बी 1, दिस विल बी -1, दिस विल बी -2, दिस विल बी 0. Your amplitude is 1, which is called as x of -t. What? Now back. What is our aim? Our aim is to add these two signals. Our aim is to add these two signals. So simply, if we consider this signal with this, इथे काही signal नाही आहे. बरोबर आहे? इथे काही signal नाही आहे. So 0 plus this signal will be this signal. 0 plus anything will be anything. So anything काय आहे? So आता मी जर axis draw केला, anything will be this. Now 1 हा signal काय? 1. 1 च्या वर काही ऍड केलं तर तो काय शेप तसाच नाही. म्हणजे हा 1 कुठे आहे? हा इथे 1, बरोबर आहे. हा तर ऑलरेडी आहे. त्याच्यावर हा कोण आहे? हा अर्धा आहे. म्हणजे त्याच्यावर अर्धा म्हणजे काय? समजते काय म्हणतो? बट नाउ 1 ऑलवेज देयर. सो 1 इथे आहे ऑलरेडी. त्याच्यावर हा कोण आहे? हा कसा आहे त्याचा शेप? असं. सो then 1 is there, nothing is there, so obviously it will be like this. So this will be -2, -1, 0. This will be 1, this will be. Yes, what is the amplitude here? Here 1, here it will be. Yes. Now what? The last step. The last step is here. What is this signal? This signal is x of t plus x of minus t. Now we have to do by 2. Yes. So by 2, obviously just we have to reduce the amplitude. We have to reduce the amplitude. So 2 is here. You can write t like this, then this like this, then this like this, and this 2 is here like this. This will be 0.5. This will be. Just reduce the amplitudes. So this what? X of t plus x of minus t divided by 2, which will give you x e of, which is your order. You can write here -2, -1, 0, 1. बरोबर आहे काय असं? These 4 steps हे असंच ड्रॉ करायचं आहे. एक्झाम मध्ये एकाच ऍक्सिस मध्ये एकाच म्हणजे तुम्ही एक सिग्नल इकडे काढला, दुसरा तिकडे काढला, असं नाही करायचं. एका स्टेट पेज मध्ये मिडलला ऍक्सिस ड्रॉ करायचा. त्या ऍक्सिस वर सिमेट्री यूज करू. असं कळलं पाहिजे की 1 1च दिसलं पाहिजे, 0.5 0.5 दिसलं पाहिजे. Either you draw by pencil, either you directly draw by pen, that is not issue. But issue is what? Your scale. Proper scale, proper symmetry. म्हणजे -1 च्या खाली सगळे -1 चालले पाहिजे. ते -1 इकडे चाललाय, तुमचा दुसरा -1 तिकडे चालला. ते कसं होतं? चेक करणाऱ्याला काय वाटतं की हा चाललंय, काढलंय, पटपट तो काय बघतो, हा सिग्नल बघतो, हे असं डायरेक्टली खालचं बघतो. सगळं सिमेट्री मध्ये असेल तो मार्ग मोकळा होतो. वाकडं तिकडे असेल तर तो बघत नाही. ठीक आहे, समजलं? इवन सिग्नल ना विल ड्रॉ. हे काढू पुसू काय? Now what we need? We need one signal minus the other signal. So this signal minus this signal. So we draw the axis first. This is the time axis. See, this signal minus this signal we want. Okay. So here 0 minus this signal. So this is what? I'll write 0 minus 1 is equal to this. दिसतंय का? दिसतंय? चालू झालं. So 0 minus 1. So negative of this signal, negative कसा असेल? If we maintain a symmetry, okay. Now 1 minus this signal, how will it be? आता एक सिंपल सांगतो काय करायचं. या केस मध्ये काय करायचं तुम्हाला सांगतो. इथे अँप्लिट्यूड काय आहे? -1 पॉइंट आहे. इथे अँप्लिट्यूड काय आहे? गेला. इथे -1 आहे. तिथे अँप्लिट्यूड काय आहे? 1 minus 1 0. म्हणजे हा स्टार्टिंग पॉइंट काय असणार आहे माझा? 0. गॉट इट? सेकंड इथे मध्ये आलो सर. इथे मी मध्ये आलो. एक आपलं इमॅजिनेशन साठी मध्ये यायचं. मध्ये का आलो म्हणजे काय? मला इमॅजिन करायचं की बाबा माझा सिग्नल कसा असेल. इथे 1 आहे त्याच्या अँप्लिट्यूड मध्ये. इथे काय? इथे मध्ये आलो. इथे 0.5 असेल किंवा 0.6 असेल, काय असेल ते असेल, कारण तो काय जाणार आहे 1.9 0.8 च्या मधनं जाणार आहे, कारण तो 45 ची लाईन आहे. म्हणजे काय? इथे काय असेल? 0.5 असेल. म्हणजे 1 minus 0.5 म्हणजे हा मला कुठं असेल? इथे कुठे असेल. इथे गेलो मी 0 ला. 0 ला काय? 1 असेल. हा इथे काय? 0. सो 1 minus 0 1 म्हणजे हा पॉइंट इथे असेल. सो जस्ट आय ड्रॉ दिस. सिंपल आहे. इथे बघा, इथे उलट. इथे 0 ला काय? 0. इथे काय? 1. 0 minus 1 minus 1 काय इथे? ओके. मध्ये आलो 0.5 minus 1 minus 0.5 minus 0.5 कुठे असेल? इथे असेल. 1 minus 1 इथे 0. इथे कुठे असेल? इथे असेल. 1 minus 0, nothing is there, so it is directly. Got it? Just reduce the amplitude. Directly I draw XO of E. This is 0.5. This is minus 0.5. Okay? This will be -2, -1, 0, 1. This is what? X of T minus X of minus T divided by 2, which will give you XO of got it? Simple. Now we'll see one last example of it. दोन टाइप मध्ये विचारतात. एक तर डिजिटल सेमच आहे, तसंच करावं लागणार तुम्हाला. डिजिटल कसं करणार? सेमच, जे काही ऑपरेशन केले ते डिजिटलला पण सेम. फक्त आता काय? एक्स ऑफ टी काय लिहिलं होतं? एक्स ऑफ टी मॅथमॅटिक्स 1 plus t plus 1 plus t plus 4t square. This is given to you. They are asked what is it? Find even and odd component of this. So simple है, x of minus t करना है, x of minus t, so it is 1 minus t plus 4t square. जिधर जिधर t है जिधर minus t put किया, जिधर जिधर t है जिधर minus t put किया. So obviously we need addition. We need addition of this. We need addition of this. So x t, or directly you can say addition of this. X of t plus x of minus t is equal to by addition 2 plus
8t square divided by 2, so it will give you 1 plus 4t square. This is what? This is what? X e of t. दुसरं काय करायचं आहे आपल्याला? X of t which is equal to x of t minus x of minus t divided by 2. So obviously minus पहिला divided by 2 नंतर घेऊ आणि काय करायचं minus. So हा 1 गेला t. So it will be 2t, isn't it? So divided by 2, so it will be t. Simple. This is one kind. Second is drawing is one kind. Drawing मध्ये पण काय सिटी सिग्नल आणि डीटी सिग्नल. सिटी सिग्नल कसे असतात? कंटिन्युअस विथ टाइम. डिस्क्रीट कसे असतात? So I directly draw one signal. See 0, 1, 2, 3, 4. So हा सिग्नल नाही कर सेट केलं तर चालेल. ठीक आहे 0, 1, 2, 3. So obviously, if you write this 0, 1, 2, 3, 4, काय झाला? X of n हा झाला X of ऍडिशन कशी करायची? पॉइंट वाइज. हा -4 आहे, तिथे -4 ला कोण आहे बघायचं. -3 आहे, -3 ला, -2 आहे, -2. याची ऍडिशन सबट्रॅक्शन. इट इज सिंपल. कारण काय इथे सगळे इंटिजर असतात. इथे इमॅजिनेशन काहीच करायचं नाही. मला काय करायचं 2 मधनं 1 करायचं, 1 मधनं 0 करायचं, 0 मधनं 1 करायचं. इंटिजर आहे काय पॉइंट वाइज जायचं. -4 ला -4 चा सिग्नल बघायचं, -3 ला -2, 0 ला 0 चा सिग्नल. That's it. So if I write x e of n, this will be equal to 1/2 x of n पाहिजे मला plus x of minus, isn't it? And second, x of n will be 1/2 again x of n minus x of. That's it. Simple. Tomorrow we'll see periodic or periodic as well as energy and power. So it will finish the classification of signals. Then we'll see operation on the signals after that. So faster जाऊया. साधारण मला वाटतं डेली एक लेक्चर आहे. पण काय करू आपण की असं काय की डेली लेक्चर 50 मिनिटाचं आहे. त्यापेक्षा आपण 2 मर्ज करून कुठली तरी 2 मिनिटाचं. कारण एका लेक्चर मध्ये कुठं सुरू होत आहे, ऍडजस्टमेंटला 5 मिनिटं जातात. हे परत ऑनलाईन वाले आपले सगळे त्यांची काळजी करावी लागते आपल्याला. त्यांची काळजी झाल्यानंतर मग तुमची काळजी, मग हे सगळं ऍडजस्टमेंट झाल्यानंतर लेक्चर कधी संपेल कळायचंच नाही. विल मेक असे स्लॉट करू की 2-2 तास, म्हणजे जे काय बऱ्यापैकी घेतल्यासारखं फिलिंग. ठीक. स्टॉप. एक काम करायचं. पहिली गोष्ट सिटी सिग्नल सगळे स्टँडर्ड, डीटी सिग्नल सगळे स्टँडर्ड. सगळे तुम्ही काय करायचं, मागचे क्वेश्चन पेपर काढायचे आणि त्यामध्ये इव्हन अँड ऑडचे जेवढे काही एक्झाम्पल कन्सेप्ट मागचे क्वेश्चन पेपर कुठे मिळतील तुम्हाला? गुगलवर. गुगलवर बऱ्यापैकी. नाही मिळालं तर मला सांगा. ओके, स्टॉप फॉर टुडे.